All right. So for short-term memory, we'll start with just the one for now. Short-term memory is where we have a temporary storing and processing for a limited amount of information in our consciousness. And so again, if we scoot back to this diagram, we're paying attention to the information coming in from our sensory registers. So because we're paying attention to that incoming information, we are conscious of that information. So our short-term memory is what's going to allow us to, for the short term, or for a very short period of time, store and process some of the information that's coming in from our senses. Pretty straightforward. But if you've ever tried to hold a bunch of stuff in your mind at one time, you would know that your short-term memory has a very limited capacity. On average, humans have a capacity of about 7 plus or minus 2 bits, and bits just being bits of information. So maybe you could remember a grocery list that has 7 items on it, but only for a short time. But if I gave you 12 items, you'd struggle to remember all of that. And so this could be called, if we're looking specifically at numbers, you would call it a digit span. So how many digits can you remember? But it could apply to anything. You could ask you to remember 7 colors or 7 sounds. Those are each bits of information. And the plus or minus means that there's some wiggle room in people's capacity for their short-term memory. So someone like me, I have a very limited capacity for short-term memory. So I have to, if I'm remembering a grocery list, if I want to be sure I'm remembering it, I'm going to keep the list very short, maybe 3 or 4 things. But other people with better short-term memories could have a longer list and do just fine. In addition to our limited capacity, we also have a limited duration of our short-term memory. And so our short-term memory is able to hold on to information for about 20 seconds or so. Again, there's some plus or minus because this is just an average. But in brackets, we're including without a control process. And again, I can scoot back to our diagram, and our control process is this rehearsal. So when I'm talking about holding a grocery list in your mind, if you had 20 seconds, maybe something distracted you, you could forget that whole list like it had never been there. But if you're able to focus and repeat your grocery list over and over, if you rehearse it in your mind, you might be able to remember the list for much longer than 20 seconds because you're using a control process to keep that in your short-term memory. And we'll come back to those processes, that rehearsal, a little bit later because it will become important, but not quite yet. And so again, we're going to talk about how do we test these things that we've talked about. So with our short-term memory, how do we know that it only lasts for about 20 seconds? And so one of the best ways that psychologists in particular like to test memory is to give people lists of words. So for example, they could give you a list and it would say apple and simple and burden and whatever else they come to mind. And they can give you a bunch of items. Again, if they go much more than say 7 or 8 items, then you're not going to be able to remember them because that's more bits than your memory can hold. But they can give you that list of words and then see how many you can recall. And so we're going to see a bunch of curves like this, and these are just our recall graphs. And so at the bottom here, we have delay before recall. And so that's saying if they make you wait before you give them back the list, so for the first part here, they're saying if you have to wait 3 seconds, and then they ask you how many of the items from the list you remember, how many are you then able to remember? So the percent recalled from the list. So higher is better. So if they make you wait for 3 seconds, you're going to recall about 80% of the list. It's not too bad. If they wait, say, 12 seconds, you're now only going to recall about 20% of the list. Your ability to remember that list drops off very quickly. And by the time we hit 18 seconds, right around that 20-second limit we talked about, you end up having almost no recall, like less than 10% recall. So we can figure from this that once we've hit that 20-second mark, we can't remember anything that was from that list. Now, I should point out that when they're saying there's a delay before recall, we also have to prevent people from rehearsing, from reciting the list in their heads, because that rehearsal process, that control process, lets them hold on to that information for longer. So during this delay, they might ask you a question. They might ask you, what's your favorite color? Or perform a simple math problem. Something to keep your mind busy so that you can't rehearse the list. And then they time it to make sure that you're only waiting about 3 seconds to answer their question of how many items from the list do you remember? Or maybe they make you wait 9 seconds or whatever. And they can do this over and over and over again, and they get some nice clean data that shows a pretty quick drop off in how much we can remember as we wait longer. And so we've talked about our bits of information, and these bits we've kind of hinted at already can be things like semantic meaning, so a word that has a meaning to it. We could hold on to visual things, we could hold on to images, phonological things, sounds, or even actions, motor patterns. So I could ask you to remember the motion of hitting a baseball or throwing a frisbee, and you could remember that action as a single bit in your short-term memory. So we can store information in our short-term memory in all sorts of different ways. So it doesn't have to just be a word or a number. It can be a visual thing, it can be a sound we've heard, or it can be an action. It doesn't have to just be words. It's just a little bit easier to talk about words than it is to talk about some of the other things. And even though we have that, we can retain 7 plus or minus 2 bits of information, and we can retain them for about 20 seconds. Just like when we talked about attention and having limited capacity there, we can have some limits to our short-term memory whereby we can have errors occur if we try and store too much information in one system too quickly. So if somebody's giving you a whole bunch of different actions, maybe, oh man, if you think back to high school and maybe you had to take a gym class and they made you do that unit where you have to dance, which is awful for those of us who are uncoordinated. But if they give you a whole bunch of steps, one after the other, if they give you more than 7 steps to remember, then you're going to get overwhelmed, you're going to make mistakes or errors because you're trying to take too many of these motor patterns, these actions, into your short-term memory in a short amount of time. It would be easier and we'd do better at remembering things if we had maybe 2 actions and a word and then maybe a sound and a couple of images. If we could spread out the information across multiple forms, it would be a lot easier for us to hold on to it. But we can get overwhelmed and make mistakes if we're putting too much information in one of those systems. And so if we have these limits, these only 7 bits of information and only 20 seconds of duration, how the heck are we functioning in day-to-day life? How do we overcome these limits? And of course we do. We have ways that our brains can get around some of those limitations. And so we have systems in place that allow us to increase our capacity or our storage duration for our short-term memory. And we're going to talk about a couple of specific ways that we do this. The first is one of the easiest, and this is called chunking, which is where you group or chunk units into larger bits. And phone numbers are a fantastic example of this, because a full phone number, including our area code, is going to be 10 numbers. That's way too many numbers if we're going off the idea that we have a digit span, or our capacity, for only 7 bits. So 10 is too many. But we tend to do pretty well with phone numbers. So we do that because we group the first 3 numbers into one. So if we're in Edmonton, then we're going to talk about 587, or whatever the other one is, because I'm bad at numbers. But that group of numbers counts as the first bit. We don't treat it as 3 separate digits. Our brains will group them together and treat them as one. And then for the second set of numbers, we group those as 4, or as 3, and the last ones we group as 4. And so we've taken these 10 digits and turned it into a grouping of 3. 3 sets of numbers is a lot easier for us to remember than 10 individual numbers. And we do this with all sorts of different things. My brain is struggling to come up with another example at the moment, though. I guess if you're trying to remember your license plate, maybe you're on campus and have to pay for parking. You can remember your license plate as the first set of 3 numbers, and then the second set of 3 numbers and or letters. And by grouping it or chunking it that way, you only have to remember 2 sets, and you can kind of trick your brain around your limit of 7, even though for most people, I suppose a license plate shouldn't be too challenging, but some of us do group there as well. And if we want to see proof of chunking in action, we can start looking at another experiment. And in this case, we're going to be looking at people who are viewing a chessboard. And so in this case, they have master chess players and they have beginner chess players. And they're going to show all of these participants a chessboard that's set up in some fashion. And we're going to look at this first graph here to start with, because this is when we're looking at actual game positions. So basically, the chessboard is set up like somebody is in the middle of a chess game. So the pieces on the board are set up just like you're playing an actual game. And to a beginner, those chess pieces on the board don't really mean anything to them. They're not going to be able to group them into meaningful positions. They're just going to look at a bunch of different chess pieces and have to remember them one by one. Whereas a master chess player, they can look at that arrangement on the board, and maybe they'll look at 3 or 4 different chess pieces, and that means something to them. Maybe that's a particular setup. Someone's getting ready for an action a couple moves ahead. So the master chess player can group or chunk all of those pieces together and treat it as a single unit. And so we can see, if we look here, so our master chess players, and we look at their correct placements, so how many chess pieces can they remember, the master chess players can remember up to 16 different pieces on the board, which is pretty great, considering our capacity should be somewhere around 7. And then our beginner chess players, they actually performed less than we would expect, and they only got about 4 correct. And so that kind of makes sense. So the master chess players can group or chunk those pieces because there's meaning to them. They can make sense of it, and they can remember that information better. But if we go to this second situation, and this time we have a random placement of chess pieces on the board. And this means instead of having the chessboard set up like you're in the middle of a game, this time somebody just put the chess pieces wherever they felt like. So the master chess player can no longer use that pre-existing knowledge. They can't link them together into a meaningful group. And so that advantage that we saw, where here the master chess players are doing much better, now everybody's doing pretty poorly. They're getting about 3 pieces in the correct spot and no more. So there's no advantage for the master if they can't chunk those pieces in a meaningful way. And so this is how we're showing that chunking can be beneficial if we can assign meaning to what's going on. And assigning meaning is going to become one of those repetitive topics for the rest of the lecture, because we'll find out pretty quickly that the more meaningful something is, the easier it is for us to remember. But again, we'll keep coming back to that. So another way that we've already kind of hinted very heavily at for increasing our short-term memory capacity is to use those control processes. So I've already talked about this maintenance rehearsal, that idea of repeating your grocery list over and over and over again in your head. So that's simple repetition. So that's how I get from here to the grocery store and remember all 4 things on my grocery list. If you wanted to do a little bit better than just remembering your list or hoping to remember your list, you could do something like elaborative rehearsal. Start bringing in additional meaning. Oh man, meaning has come back again already. So by elaborative rehearsal, I mean instead of talking about your grocery list is eggs and milk and bread. Okay, so to elaborate on that, instead of just saying, okay, eggs, milk, bread, eggs, milk, bread, which is our simple repetition, we could say, okay, well, I want eggs and milk and bread because I'm going to make French toast. So I'm going to focus on the meaning. So I would mix eggs and milk together and then put bread in it to fry it and make French toast. So I'm elaborating on the process. So instead of just focusing on the name of the things I'm getting, I would think about how I'm using it. I'm going to get some meaning out of those words, and I'm going to remember it better because there's more information there to help me remember. And again, that focus on meaning and adding more information is going to keep coming back as we talk about ways to help us remember things.